Welcome, ladies and gentlemen, to our webinar about the vertical turning machine VM9. My name is Oliver Hagenlocher, and together with my colleague Achim Tromsdorf, we will present you today insights, background information, advantages, and of course, application examples about this machine. Achim Tromsdorf is at EMAG our specialist for the modular standard machines, and the VM9 is part of our modular standard machine series. Therefore, he is the perfect person for us today to give you all these background informations. But before we start, let me shortly introduce to you our webinar software, because you can, this is a live webinar, you can ask questions directly to us, and we try to answer these questions, of course. There are two ways to ask these questions. First way is to ask the question with the chat function. Here, everyone in the webinar or participants can see your name and can see the question you ask. If you ask the question via the question function, then only we are here in the webinar studio and the people in the background can see your name and the question, and they give the question directly to us, and we will try to answer it. So that's it from the beginning, and now Achim, start with the presentation.
Thank you, Oli, for the introduction. Hello also from my side. I would like to give you a short overview on our modular standard machine VM9. As Oli said, I'm, let's say, the specialist for our modular standard series, well-known machines like VL2, 4, 6, 8, the VT machine series, and also the VM9, which is part of the modular standard family. Short view on the machine itself. So for those who are well familiar with our principle of modular standard EMAG machines, this is not a new side on a machine, because the base and the general concept of the machine is similar to that of our VL and VT series. The only difference is that spindle and turret is vice versa mounted on the bed frame, to say it very easily. Advantage of that machine is that we have a very small footprint. As you can see it here, we are around about 5 square meters layout on the footprint, very short, very not that wide, with 1.8 meters and the height of 3 meters. If you compare this with the normal lathes you normally use for...
You mean horizontal lathes?
The horizontal lathes, yes, you will normally use for the production of more or less bigger parts. You can see that we are reducing your floor space with that concept.
I think this is an advantage also for all the VL, VT, VM machines. They all have the same.
They have all the same advantages, yes. Some words on the dimensions. The machine is focused on the production of components, round components, or even more fragile components, for a diameter of up to 450 mil dia and component weight maximum 300 kilogram. If you compare this to the numbers which we are used to handle in our vertical machines VL, you can easily find that we can here deal with the more heavier and more big-sized components.
So this is also one of the reasons why we have this machine.
Yes. Here you can see also that we are able to machine components up to a height of or length of 300 mil, and with the use of a chuck of up to 630 mil dia is also, with this swing diameter of 700, possible on that machine. Oli, you said that we normally are dealing with the pickup principle, so
Yes.
EMAG is very well known and proven for that. Why is EMAG now changing the concept? And here I will show you some goals we had during the development. So just to say that we have developed the machine together with all the other modular standard machines. We start with the developing of that machines in 1913, 14, and we developed the entire series up from VL2 to the VM9 machine in one shot. And all of these machines will be, let's say, revised twice a year with new side of components, of programming and everything like that. So the VM is still a part of the modular standard family, also concerning the developments. What parts had we in mind when we decided to change the concept and go to the bottom-down mounted spindle? So we wanted to give to you a machine where we can use also complex clamping systems, especially for large size, large dimensioned, and heavier parts that are much more sensitive on deformation in clamping. Because as you all know, if we want to machine a heavy component with a pickup type machine, you need to have some certain and large clamping forces to keep the machine in the component in the process on the chuck. And if the component is more sensitive for deformation and the clamping force has to be reduced on a minimum, then it's easy to understand that then the component has to put down on the bottom-down spindle. So even for prototypes or for small batches, small series, only one part batch, also for parts family, and then when the use of stainless steel, titanium, Inconel, and all these heavy cuttable materials has to be in the focus, then such a machine with a heavy spindle power has to be used in that. And this gave us the input to create the VM9 machine. Some goals what our developing department had in the beginning. So we want to have the uniform machine concept coming up from the VL up to the VM9, so there is no difference in the basic structure of the machine. Also the small footprint, all of our modular standards are equipped with. A common part strategy is also important. If you are using EMAG modular standard machines, you can find the same type of parts and same type of parts sub-suppliers that you used to know from our modular standard pickup machines. Here, a very, let's say, one of the prior view we have on the accessibility of the working area, because if you will manually load your workpiece onto the chuck, it is a need that the operator has to have a good accessibility to the working area to get access to the chuck, to get access to the tools, and this in an ergonomic way so that it's comfortable for the operator to maintain the machine. With the machine, we are able not only with the manual loading concept, but we can add also automation systems like crane loading, unloading, like a portal loader, gantry loaders, and up to the robot loading systems. Everything is possible with this VM9 machine.
Maybe let me interrupt here for the first question. What are the advantages of the bottom spindle compared to the hanging spindle? You mentioned already some advantages.
Some, yeah.
Maybe there are some more you can explain?
I can go more in details in that, because more or less I tried to show this on that slide. Where is the line between when is the use of a hanging spindle or a bottom-down spindle more useful? Even then, when the workpiece has a geometry and a sensitive deformation is expected when being clamped in the machine, because as you know, in the hanging spindle we need more clamping force to put let's say the workpiece on the top of the machine. Then we have this integrated automation in all of our pickup machines, and in this automation system we have only, let's say, the possibility to load and unload workpieces, or to handle workpieces up to a weight from around about 50 kilograms. So as I explained, with a bottom-down spindle, we are not limited, or we are limited onto the 300 kilogram, but most of the components which have to be machined at our customers are in that range.
Okay.
So one is the weight of the component, where the two systems are dividing, and then when you see that you only have to machine one prototype component or even a small batch or medium-sized batch, then it's, let's say, more economic to use a machine where you can also do the manual loading.
Okay.
So I try to figure this out here on the scratch. Let's say, the most, let's say, reason where it's only possible to use a bottom-down spindle is if you have to use a very special clamping system, not only a 3-short chuck or 6-short chuck or something like that, but a magnetic chuck or such a clamping device. This you cannot use in a hanging spindle. So on what types of workpieces was our focus when we developed the machine? Mainly on parts of trucks. Here, as a sample, a brake disc. And also we have the focus on hubs and things, not only for trucks, but you can also find components like these in agricultural machines, in construction machines, and machines like that. So this is the focus where we put on when developing the machine. Everything here in the axle of a truck. Brake disc you can find also in passenger cars. Normally brake discs of passenger cars will be machined with pickup spindle machines in big batches, in big series. But if you see that even in passenger cars, it could be possible that brake disc can have a diameter of up to 400 millimeter diameter. Then in low batches, because these big brake discs are normally in, let's say, high-class cars or with small batches and low series, then it makes sense not to use a very productive production line to produce these, but then to have a, let's say, more economic machine for that.
Another question. I think it's not our core topic, what we speak about today, but coated brake discs are always an issue. I think they mention here Euro 7. What role do they play in trucks?
They will come up.
Okay.
To say it quite shortly, so as it's well known that in 2025, for all passenger cars, the need of coated brake discs will come up to, let's say, reduce the pollution, fine dust. And for trucks, they will come up in 2027.
Oh, also, more time.
So they have more time. We have 2 years more time, even for us to develop or to enlarge the concept what we are offering actually for passenger car brake discs for pre-coating and for the grinding of the brake discs with our machines. Maybe we will have another webinar for that.
We will have a webinar in April or May. I don't know the exact date now, but we will have a webinar. But we will have a webinar in March about the general laser technology and the possibilities we have with laser as a tool. That we have laser welding, also laser cleaning, and I think there will also part of laser coating.
So it's in that direction.
If you're interested in that kind of webinars, you can see that on our homepage at emag.com.
Okay, but for the trucks, truck brake discs will come up in 2027 then, and up till then, I think most of the passenger car brake discs will be coated.
Okay.
So especially for the purpose, not to coat, but to green turn, to pre-turn and finish turn the brake discs, we have a special application on the VM9 created, which is in principle only a special brake turret disc. This turret disc is able, in this turret disc we are able to wear a straddle tool holder, special straddle tool holder, which enables us to finish turn the braking surfaces, both braking surfaces in one cut, which guarantees then accurate flatness and surface guarantee. So for this purpose, the VM9 can be equipped with this special turret disc.
There's another question. Why we are promoting here spindle down concept with robot automation? Does it make more sense to switch to a pickup solution for series production? I think we should also discuss a little bit about loading and unloading time of different kind of concepts, because I think that question goes in that direction.
Yeah, with the loading and unloading time in the pickup, when we are using pickup machines, we have a loading and unloading time with this internal automation of around about 6 to 8 seconds from piece
for these large parts.
These large parts,
And if you compare it to a kind of robot automation, comparable robot automation for brake discs,
the robot can be faster. It depends on how many machines should be loaded and unloaded with one robot.
Okay.
If you take one robot to load one machine, it depends on the speed, the speed of the handling speed of the robot. Could be even in the dimension of 5 to 6 seconds.
Okay. So this is comparable.
It's comparable, yes. Yeah. So loading and unloading also, when loading and unloading also, you have the influence of the clumping jack.
Okay.
So when you have a 3-jaw jack, for example, in a pickup machine, you need to take some time to fix the jaws on the component. In that case, the jack can be closed quicker.
Okay, but with spindle down, you have...
Spindle down, you don't need to...
but you need a kind of cleaning cycle for different
You have
chips.
the same cleaning cycle. Yeah, you have the same cleaning cycle with air or with water.
Yeah.
Brake discs normally will be machined dry, so dry cutting. Then we are using air to clean up the the surface of the chuck. In the hanging spindle, we also do that with air. Okay, the chips are falling down quicker and more easier from the pickup spindle than from a bottom-down spindle. So this is one of the differences.
Okay.
So hubs I already mentioned. Also for other type of machines. Then this gives a small introduction on an axle of a truck. So here you kind of can find the brake disc, you can find the hub, you can find also a brake drum, which is also an interesting component, can be machined on the VM9. And the third big volume component which we had in mind when developing the VM9 is a differential housing of trucks. Because differential housing production is made for passenger cars in the pickup machines very effectively. But here we are talking about dimensions of up to maximum 200 millimeters of the cage. In the truck business, we have more up till, let's say, 300 or 400, even 400 in the cage on the big machiners. And also with heavy weights, we are talking about weights of round about, let's say, 45, 50 kilograms. And this is not very, let's say, effective to be handled in a pickup machine.
Okay.
We have solutions for this in the VSC world with our customized machines, but not with a, let's say, serial standard machine. This is only here with the VM9 possible.
Okay.
Nice component. In these big dimensions, you can find the splitted differential housing with cover, an end cover with a splitted housing then. And then also the other components which is forming then the differential drive is the pinion gear then and all the other gears around.
Maybe we can add here, we also have laser welding solutions for differential housing and ring gear. This is the ELC 600 machines that from EMAG Laser Tech. Also, we have gear cutting solutions in-house for also ring gears for gear shaping and also gear grinding.
Gear shaping, gear grinding, and also gear hopping. Yeah. With our daughter company,
EMAG SU.
Machine SU, EMAG SU. Yeah. So the entire process chain can be
from raw to finish.
From raw to finish, yes. So, just to give a impression on how a component will be machined in the VM9, here a short, quick video without any chips falling down.
Maybe we have to say this is not the original length. Normally this video runs around about 10 minutes, so it's a little bit too long for our show today.
So we shortened that even to give you the overview, what are we doing in Op 10 and Op 20. So we have 2 operations clamping on this cover workpiece. We have the turning operation of the face, and on the inner board dia, then we have some bores in the OP10, axial and radial. In operation 20, we are doing some turning on the outer diameter. And here we have also milling operation here on these contours, and then some boring operation as well. And here the overview, 2 operation on 2 machines, manual loaded at one of our customers in that configuration. Manual loaded for this sample we already saw. On the left side I have a picture. where you can easily see how ergonomic it's possible for the operator to load manually such a workpiece.
Yeah, the spindle is really near at the door.
Yeah, it's really near, and the height is 1 meter, nearly 1 meter, 1040 millimeters in height. So it's very ergonomic for the operator to get access to the working area, especially to the chuck. He can get access via the front door. This could be equipped with an automatic open and shutdown mechanism. In the basic machine, it's only manual to open and to close. So we would recommend this for the machining of parts in batches of 1 to, let's say, 20 workpieces. If from the weight, from the side of the weight of the workpiece, this will enable the operator to do it manually. Even he could get help from a crane or manual crane or something like that. If we have to machine larger batches, let's say of up to 1,000, we would recommend to interlink 2 machines or even 3 or 4. It depends on how many operations will be needed to produce the workpiece. Then we will add a portal loader or a gantry loader or other automation system. So you can then form also a line, so to load the machines from the top. So if you open the automatic front door, you have also access from the top, because we are opening with the front door also a part of the top of the rooftop, and then the loader has access from coming above onto the chuck. Third way is to use a robot. Robot automation is more, let's say, flexible. You can add within a robot automation not even more machines around the robot, but also peripheral, if needed, peripheral operations like washing, brushing, I don't know. All of this is possible with a very flexible 5-axis robot solution. Here we can also have this, what we mentioned before, for this high volume production of brake discs.
Yeah.
1 robot, 1 machine, then we can have a very productive system.
Okay. Another question: what should be the ratio of turning to milling to get the most out of the machine? I think this is related to the video we shown that there were a lot of milling and drilling operations.
Yeah. So the ratio should be 70 to 30%, 70 turning operation, 30% milling and boring operation. If more is needed in boring or turning or threading operation, we would recommend only to split the machines to do the turning machine and then a machining center, a machining center for these other operations.
Okay.
But 70 to 30 roundabout would be fine. Here a view on the footprint of such a solution: OP10, OP20 machine, VM9 with a portal loading system. If you compare this maybe with a horizontal machine solution, with 2 horizontal machines, you need much more floor space. If you're using a horizontal machine with counter spindle, it could be reduced, but so compact, like a system consisting of 2 VM machines, could not be realized from our point of view. This is a pretty nice configuration. 1 robot is loading and unloading components into 3 VM9 machines. We have a centralized loading of raw part conveyor and an unloading conveyor for the finished parts, and the robot is doing the handling in between the machines. He will get access to each machine through a second automatic door on the, in that case, left side of the machine. We can also offer so that the machine is very good accessible, not only from the front side, but also from the left side in that case. And here you can see very good that it's also possible, this machine concept is so open that we can position our chip conveyors in the way it's needed, from left side, the outlet on the left side, on the right side, back side, everything is possible.
Yeah, I think even with the robot automation, the accessibility is really good at that line.
Yeah.
You have always access to the front door, to the control. You have access to hydraulic, electronics. It's really often you see in the field robot automation system where the accessibility is really a problem.
Yeah, because they are using then the front door, and it's not possible for the operator to have also access.
Yeah, especially when the robot opens the door.
Yes. Yeah, in this configuration with our machine, it's possible for the operator then, if it's required, he can get access through the front door in the machine. In that case, the side door is closed and everything is safe.
Okay, that's good.
According to CE regulations, that's really important. So some words on the machine structure. The machine structure is comparable to all of the modular standard machines. Let's say the central point of all of our modular standard machines is our column made of our mineralite material. So we have this column casted out of mineralite. Mineralite is, we invented that material many years ago, and we are using it for all of the EMAG machine bed frames. This has a good damping condition. This has good conditions concerning thermostability, and this ensures higher surface quality on the workpiece as well, and much longer tool life, because when better damped, the tool is not so fast consuming. Then you can see here we have these linear guideways also from sub-suppliers, well-known German brands. We have if you compare this machine here, it's written the linear measuring systems are optional in X and ZX. Normally the machine is equipped with rotary measuring systems, which is pretty good when you use the machine only for rough turning operations and things like that. But if you are requiring higher quality and also doing the finish turning operations, it's required to add this optional linear measuring scales in X and Z axis. So we have a weight compensation for the cross slide, because in that case the cross slide is on the column and the spindle is on a console on the bottom of the column. When we have our pickup machines, the cross slide has the spindle with it, and the turret is part of the bottom. Some numbers on the feet and speeds. We are using big dimensioned ball screws and linear guides.
One more question, or two more questions. Is automation really an issue? Isn't it more interesting for low-wage countries and manual loading? I think we have to discuss a little bit the difference between Asia and Europe and Americas.
Yeah, especially in Asia, where let's say mainly our competition is located, we are selling these machines let's say, to 99% manually loaded. So because in these low-wage countries in Asia, in some low-wage countries in Asia, a manual loading and unloading of a machine is okay. Also, if you see that one operator is maintaining one machine. So this is the most economic system for them. In Europe and in America, it's the other way around. Most of these machines we already sold are equipped with automation. Not only coming from EMAG, the automation, also we have a lot of customers, they add their own systems or their own robot systems on this machine. But this is a matter of the wage.
And but I think you already answered this question.
The linears.
Why are the linear measuring system option on the machine?
Some words on the spindle. We are using a maintenance-free synchronous spindle motor. By the way, just a word, nearly 85% of all the components which are in our EMAG machines are consisting of are homemade EMAG in our production facilities. So, which means spindle, turret, bed frame casting, sheet metal production, all of this will be done by our colleagues in our production facilities. So with this we can guarantee for the quality, not only for the components, but the quality of our components will be granted for the quality you will have on your workpiece after that. So I already mentioned that with that we have ergonomic loading and unloading and a quick machine setup coming with this. And just a word for on the chip flow. And you see that I have written here unrestricted chip flow under the spindle.
Nearly unrestricted.
Nearly unrestricted. The advantage of a pickup machine, where we come from the EMAG, is that the chip flow is unrestricted.
Absolutely.
Absolutely. When we have now the spindle mounted on the bottom of the machine, okay, it's in the way of the chip flow, but we had a solution for this. If you see that we have here some kind of roof type sheet metal, so if the chips are falling on the sheet metal, will be then directly linked here into the vertical flow around the spindle. So we would take care that the chips will have also good flow into the chip conveyor on the bottom. So we equip the machine with everything to guarantee the most possible unrestricted chip flow.
That's a good sentence.
So just some numbers on the main spindle. As you can see here, we are using a 38 kilowatt spindle with a torque of 500 in max 650 Newton meters. A torque full power of the spindle is from 720 RPMs on, and we have a maximum spindle speed of 3000 RPMs.
One short question. What is the delivery time of the machine?
7 months, approximately.
Thank you.
For we are producing 85% of all the components. We have this in our hand. It's depending on what is our production, in the production set, actually, the requirements. But round about 7 months. So I already mentioned our turret. So here this is the well-proven EMAG turret we are using in nearly all of our EMAG machines. We have produced around about 15,000 turrets within the years in that concept. And we have here added a second type of drive. So the normal concept of the drive of the tool in our turret is the conventional way with a motor, then with a gear, bringing the turning onto the tool. We have a second possibility if we need more RPMs and if we need even more torque. Then we can put the drive inside the turret disc. We call this HP turret, high performance turret. Here's some numbers. So with this kind of turret, it will be possible to use a torque of maximum 56 Newton meters and a power of up to 75 kilowatt in 10% ED, but in 100% we are still working with 33 Newton meters and 10 kilowatts. It's a good number. Maximum speed on the tool, we can have the 10,000 RPMs and full power from 3,000 RPMs on.
Okay, just let me interrupt here. We got another question. I know this type of machine mainly from Asian machine tool builders.
Oh, yeah.
What advantages do you offer over these manufacturers?
To say it that way, we know that we have a lot of competition from Asia. Also, good machines, they are producing good machines in the market. But if you compare the ratio of power on the spindle, power on the workpiece, stability of bed frames and things like that, our price ratio is in the end as well as economic.
Okay, so we do have a good price-performance ratio. This
yes.
is what we can say to these machines, and it's not always 100% comparable because the performance of the machines is different.
Yeah, it's always a matter of what is your production facility philosophy.
Yeah.
If you have to do only the green turning, the pre-turning of components and things like that, and it's okay for you that you can have a spindle with 18 kilowatts or such, then you can also use a machine which is not of that rigidity and not of this power spindle that we have. But if you are going more in the fine operation, then in the finishing operations, and even then, if you see here with the bores, you need repeatability also on the putting your bores in the workpieces. Then you can find very easily where is the difference.
Okay.
Just one word, I already mentioned that. We are very proud to have a patent, an additional patent on the VM9 machine option. So we have designed a special measuring gauge. In that case, a radio-controlled measuring gauge. For sure, we don't produce the measuring gauge, so we are supplying that. But the special and patented thing is the cover. So if you are not in the measuring process, the measuring gauge probes should be covered and will be covered with this sheet metal cover. This will be opened and closed via the drive of the turret. So it's like a driven tool, and it could be maintained like a driven tool in and on and off. And this gives the movement to shut and to open the cover for the measuring gauge to protect him against pollution, chips and abrasion and even damage. In that case, it's mandatory to equip the machine with the linear scales, because the linear scale gives then the repeatability and the accuracy of your measuring process. Here's a quick view inside our, let's say, machining room, where our components are. Here the electrical cabinet, you see the FANUC components. Machine is equipped with FANUC control and even then with all drives and all the needed electrical components from FANUC. Here a view inside the hydraulic and pneumatic area. You can see here you have easy access. Everything is structured and easy to maintain even for the service department. So this brings me to the summarize. To summarize all the advantages you can get with our VM9 modular standard machine. First, this ergonomic design for the operator to have a good accessibility and ergonomic accessibility on the working area with his workpiece. It's easy to maintain with that. Then we have this powerful maintenance-free main spindle with directly driven, also with a view of the highest productivity quality. Then we have this driven tool turret with 12 driven tools and a really short tool-to-tool changing time of 0.3 seconds. We can have this measuring probe I already showed to assure the process quality. User-friendly, it's the complete machine. You can see it in the picture on the right side. Easy for the service guy to get access to all the components. We have a small footprint, and even we have a variable concept possible for the loading and unloading from manually by crane loading up to the robot automatic loading and concept. So,
thank you very much, Achim.
Welcome.
That's the end of our session.
Yep.
Thank you very much to you to join our webinar session and to be interested in our products and solutions. Before we close the session, let me give you some information about the upcoming webinars. We will have next week a webinar about our vertical pickup turning machines, advantages, automation strategies, manufacturing strategies, and IoT. Then we will have mid of March, the laser webinar I already mentioned. And end of March, we will have a webinar about universal external cylindrical grinding machines. So thank you very much again, and I wish you a wonderful day. Bye-bye.
Bye-bye.